Hey guys, we're going to look at the review guide. This is part 3, so we're going to be focusing on, in this video, pages 16 all the way down to 20 and 21. So we're going to go through types of functions, average rate of change, domain and range. We'll talk a little bit about linear functions and some quadratics. So I'm going to go ahead and pause this and skip down to page 16. So on page 16, talking about different types of functions. So we got some generic equations for those. So you got linear, you got your exponential, your quadratic with your square term, and your absolute value function, which is the absolute value signs. And some of the things we're going to talk about with this is for the linear functions, you got some patterns displayed. A pattern with repeated addition. So like, for example, if you had something where you had a table, x and y values, and something like 7, 10, 13, this would be repeated addition because you're going up by 3. Is that rate of change is constant. And then for exponential functions, there'd be a pattern with repeated multiplication. So something where you would have 3 values or more. Let's say we had numbers like 3, 9, and 27. So like in that case, you're multiplying by 3 each time. So they want you for the first part to go through and, based on what it says, to say what type of function it is. And then with certain word problems, again, you're looking for what the change is. Is it repeated addition or multiplication? So kind of going with the 2 multiple choice questions below. Okay. Moving on to that, we got rate of change. Okay. So this one's asking for a rate of change for everything in the tables from -1 to 5. So when you have one of those inequalities, what you're going to want to do is you're going to want to take and find the y values for those x values. And for example, if I had, let's say, -1, 4, and then I had 5 and, let's call this one 16, to find that average rate of change, you want to subtract the y's and the x's. So like 16 minus 4 would be 12, 5 minus -1 would be 6, and then you want to divide the y's by x. So you got 12 divided by 6, which would end up have a rate of change of 2. And just make sure if you get a decimal, use the math button in the calculator, and then you can use the option that says fraction, change it to a fraction. So just make sure you got 2 coordinates for this section as you're attempting to do each question. Okay. Then kind of moving on from there, you got domain and range. Okay. So let's talk about, and we're going to do this first one here together, the graph of f of x. So I'm going to pull out the calculator. And what I'm going to do is go to y equals, and I'm going to type in that expression. So we got a -2, math button, ABS, absolute value. And then we got x plus 3 in the absolute value signs. I'm going to make sure that I have the graph and table set up also. It's a good idea. So what you want to do is see if there's any, first off, for domain is the x values. So as I'm looking around, it looks like the graph keeps extending. So if you have a graph that keeps extending left and right, then when you write out the domain, the x values are going to be everything from -infinity to +infinity. And then in the case of range, it looks like the graph gets as high as 0, but then on each direction, whether you're going left or right, it goes down. So that would mean that for the range, we're going to have the y values are going to be less than or equal to 0. And you want to include the equal part because 0 is one of the values in the table. Okay, so that's what you want to look for when you're doing the domain and range. Does it stop? And if it does stop in one direction, think about the values around it. Are they lower or higher? Because you have to write that as an inequality. So, moving on from there, talking about a piecewise function. So with these right here, you really want to focus on, you put each of these values, each of these two would go into y equals. So you would do those one at a time, okay? And then these represent the table values you're focusing on. So I would graph this equation, absolute value of x, only from -3, and then I would stop at 1 with an open circle. And then I would graph 4 from 1 to 8, and then those would both have closed circles on them. So when you do a piecewise function, that's kind of what you want to focus on, okay? And we talked a little bit about linear functions already. You may have to use the slope, which is again just the average rate of change. You subtract the y's and the x's. So like for this first one here, this first section, they want you to get y by itself. So I'll do an example to show you. So there's a equation kind of in general form. What you want to do is move the x's on each side to the other side. And if you're in class right now, I also have an example on that on the review board. And then you want to divide everything by 2. So you get y equals -2x plus 8. So now you're able to tell and graph that, and you can tell what the y-intercept and the slope is, because the y-intercept would be 8 at 0, 8, and then the slope is -2. So that means it's going down 2 for every one you move over. So that's kind of there to help you with that. With this middle section, when you do slope, same thing as average rate of change. So we talked about that a little earlier when you're working on those questions. And then with quadratics, the last section, I got on here some of the key vocab: vertex, zeros, axis, symmetry. Okay. So, and again, when you're looking at a graph, and I'll label some of those points on this graph. Okay. We got zeros or roots. You'd write those coordinates down. Those are going to be your roots or zeros. Okay. The axis of symmetry is going to cut it in half. So the line that would be of this form: x equals, and then what number does it hit? And then your vertex is a coordinate. So what coordinate it is that, where it kind of cuts that graph into 2 pieces, 2 equal pieces. And then the only other part for the quadratics that you want to kind of focus on, if you look at like questions 6 and 7, with some of those real world examples, okay, and what you want to focus on with this after you graph it is thinking about the situation itself. In the context of the question, it says student drops a ball from the top of a 100-foot building. Okay, so focus on what the variables mean. Like this one talks about height and time. So time would represent the x values, and height would represent the y values. So you want to use that equation along with some substitution to tell you what numbers to substitute, and then think about again the context of the question. They're asking if the ball hits the ground. Well, if the ball hits the ground, imagine I got a ball right here, it's getting dropped. Okay. The ground itself here would represent a point, maybe like 6, 0, because that 0, the y value represents the height. Okay. So remember, the coordinates represent time and height. So if the ball hits the ground, that means that the height's going to be 0 in that case. So again, you'll see some of those context questions on the Regents. And usually with equations, they want you to do some sort of substitution with them. Okay. So again, if you have any questions on these sections, just let me know in class. Otherwise, good luck with all the questions.